So the learning objectives for this short video are 1, to identify and apply conversion factors from mathematical representations or written as sentences, and then to take those and construct a framework that you'll use to solve multi-step unit conversion problems. So an example of a more complicated unit conversion problem, which is our second video, is shown here. And this is how we take a lot of times units that we're not maybe comfortable with. We might not even understand the context of them, but if we can pull out things that are equal to each other, we can solve a more complex problem like this. So for now, I want you guys to read this problem. How many stars are the same as 10 squares? With information provided below. Pause it and try to solve this problem. When you're done, hit play again. What we see if we try to go through this in a very logical manner is we have to identify from the question what our starting quantity is, and what we're trying to find out. So our starting quantity is in units of squares, and this is our ending units. But what's really important is that we're actually not changing a quantity. We're not starting with 20 cents and ending up with 50 cents. We're saying, well, how many cents are the same as $0.2? That's kind of what we're trying to do here. So to get there, we know that we need to use this information below. So at some point, we're going to say we want to look at starting with 10 squares. We're always going to make it a fraction if we're converting between units. How do we get that to describe that in terms of stars? So first thing we want to do is we're going to look at this equality on the left side. We know that if we have 5 squares, that is the same as one triangle. So one way to make this a usable representation instead of just 5 squares equals one triangle, we're going to divide both sides by, just like you can do with any mathematical representation, both sides by the same. What we get on the right side is 1, and on the left side now we have a conversion factor. We know that if we have 5 squares over a triangle, we know that that is equal to 1. So we can multiply anything by 1, it doesn't change what it is. The same thing with this conversion factor here on the left side. What if instead we had divided by 5, both sides by 5 squares? Then we'd end up on the left side with 1, and on the right side we would end up with triangle divided by 5 squares. That is another conversion factor. We can multiply anything by these, and it will give us back the initial quantity in different units. So what we say is this allows us to convert between squares and triangles. Let's do the same thing on the right side here. So on the right side we have 2 triangles is the same thing as 3 stars. So we can say that I know if I have 2 triangles, that is the same as 3 stars. So let's think about how we're going to use this. So let's do mathematically the same thing we did before. Let's divide both sides by the same thing. That means on the right side now we have 1, and on the left side we have a conversion factor that is the same as 1. So that is 2 triangles divided by 3 stars is a conversion factor. We can multiply anything by that, and it'll allow us to convert between units without changing the quantity. Instead, if we divided everything by 2 triangles, we would end up with 1 on the left side, and on the right side we have 3 stars divided by our 2 triangles, and that is another conversion factor. So this allows us to convert units from triangles to stars, or you could actually say the other way around, stars to triangles. And the same thing back here with the orange one we did, or triangles to squares. So now let's go down to our bottom problem. If we're trying to start with 10 squares and we want to get 2 stars, unfortunately neither of these conversion factors allow us to go from squares directly to stars. But hopefully we can see a path here that we can now convert from our squares to triangles. So let's do that first, and then hopefully next we can go from triangles to stars, and those 2 steps will allow us to get to the final unit that we want. So in our class we do want to see everyone using these units explicitly written out in the fraction format that we have here. So if we're going from squares to something else, we need to make sure that the squares are canceled out in the conversion factor, which means that we're going to use the conversion factor that is in orange and red now. When we do that, we see that we cancel our squares out. We always double check that. So now we've converted squares to triangles, but we need to go from triangles to stars now. So if we look at the different options that we have, I think that we can see that we would want to cancel out our triangles that are on top, so they need to be on bottom in our conversion factor. So the one that's in green and red is the one we're going to use. And if we once again verify that our units will cancel out, then we can see that in the end, the only unit we have on top is stars, and our numbers are 30 stars. And then on the bottom, all of our units canceled out, and we have 10. That means that this can simplify down to 3 stars. In essence, this means that we just found out that 10 squares is equal to 3 stars. If you notice, I wrote this out intentionally to look like the ones above, and now we do actually have another conversion factor where we can go 10 squares over 3 stars equals 1, and we could also do 3 stars over 10 squares equals 1, and those are 2 new conversion factors. Let's practice this now with adding another conversion factor, but this time it's in the text form. So go ahead and pause. Try to determine starting quantity, ending quantity, and make sure we know all of our conversion factors that we can use. After you've looked at this a little bit, I hope that you have actually taken this conversion factor here that's in the sentence format and written it out. 3 stars are equal to 1 circle, and I'm going to do this 2 dots in it just to make it different from a 0. So now we can see that we have 3 different conversion or equalities, we'll call them, which you can make conversion factors from. So then let's go up to the top and let's say what's our starting quantity. Our starting quantity in this case is 30 squares what are we trying to get to? We want to know how many circles that is. So this is the ending unit. Okay, so now we know where we want to start, where we want to get to, and we have now 3 different conversion factors, and maybe we should write out these conversion factors since we haven't done those yet. So we could do the math steps if we wanted to, or we can say that after we do those, that we know that this is equal to 1. We also have 1 circle over 3 stars is also equal to 1. So now we have 2 more conversion factors in addition to the ones we had on the last page. So let's go ahead and write out our starting quantity. We know that we have 30 squares this time. We're going to write that over 1. And now we're going to use our different conversion factors. And I can't remember the exact colors we have, but I think the orange one that we had stated that if we have 5 squares, that is the same as 1 triangle. That allows us to convert from squares to triangles. Now we want to convert from triangles to something else. The only way we have to do that is, I believe it was green last time, is we know that if we have 2 triangles, that is the same as 3 stars. That allows us to then convert between triangles and stars. And lastly, we know that we want to convert from triangles to circles. And lucky for us, we now have 2 different versions of that same conversion factor. So we want to make sure that we use stars in the bottom, which will cancel out our stars, and end up with 1 circle for every 3 stars. If we go through all this, we make sure that all of our units cancel out. We can look carefully through all of our units, and we see that the only units we're left on the top is circles. And we have 30 times 3, so that's 90. On the bottom, we have 5 times 2 times 3, so that's 10 times 3 is 30, no units. We can simplify that down, and we end up with 3 circles. So, if we were to write another equality, we could say that 30 squares equals 3 circles. Or, if we wanted to be even better, even simpler about this, we could say that 10 squares equals 1 circle. Might be the simplest of our conversion factors. All right, let's try a much harder one. Now we're using totally different conversion factors. These are newly written. So go ahead and pause, and then try to work through this problem on your own. Focus on writing out the equalities first, then the conversion factors you have, and then solving the problem. Okay, now that you've tried, I hope that you're able to pull out some of these conversion factors. So the conversion factors that we pulled out are 1 triangle is the same as 2 stars. That's the first one. 2 circles is the same as 3 arrows. 5 squares is the same as 1 triangle. And there are 3 stars per circle. That's where all of those came from. And then our question is, how many arrows are there for every 60 squares? So what's our starting quantity? In this case, our starting quantity is the one that we know, and the question is, well, how many arrows is it? So we want to convert that to different units. Okay, so let's go ahead and start with 60 squares over 1. This allows us to be really clear that that's on the numerator. What conversion factors are we going to use? We now have a lot of conversion factors, and we may or may not need to use all of them. Sometimes we're given extra information that we have to sort through. So if we were to do our mathematical representation, we could do 1 triangle over 2 stars equal to 1, which is also equal to 2 stars over 1 triangle. And we can do that for all of these. I hope that you've done that and written out your individual conversion factors. So the first thing that we want to do is we want to try to convert our squares into another unit, and it looks like the only one that includes squares is this one here. So we have 5 squares, 1 triangle. So now we've converted between squares and triangles. Next, we want to try to get closer to arrows, always keeping arrows in mind. So in order to get from triangles closer to arrows, the only conversion factor it looks like we have is the top one here. So we have 1 triangle, 2 stars over 1 triangle. That allows us to convert once again from triangles to stars. And then we need to go from stars to get closer to arrows. To get from stars, convert to something else, it looks like we have to find the number of circles. So we have 1 circle over 3 stars. So now we know that for every 3 of these stars, we know how many circles there are. And then finally, it looks like we have a direct conversion finally between circles and arrows. So we have 3 arrows for every 2 circles. Now, we want to go back and make sure that all of our units canceled out. On the top, I only see the arrow. On the bottom, I don't see any units. So that's great. If we multiply everything out, we have 60 times 2 times 3. So it's 120 times 3. That's 360 arrows on the top. And on the bottom, we have 5 times 3 times 2. That's 30. And if we were to simplify that down, as I imagine you guys will be doing, I'm going to take out my calculator to make sure I don't mess this up. 360 divided by 30 is 12 arrows. So if we want to go back, we can say that the 60 squares through a number of different conversion factors is equal to 12 arrows. And now we have 2 more conversion factors. On the next video, we'll do a more complicated problem that's not just shapes, but I really need you guys to use, or we need you guys to use, this method for how to set up and clearly show the steps you're doing in conversion factors.